So we're going to continue looking at solving systems of equations using the method of substitution. This is our first of two algebraic processes that we can do to find the point of intersection between two lines. So we saw yesterday we can do that. If we have two equations with two variables, we choose one of the equations, get one of the variables by itself, and then substitute that into the other equation. The only difference for today is that we're going to have to write our equations first, and then we will solve them. So at a dance recital, there were 220 people. Tickets cost $9 for adults, $6 for children. They collected $1,614 in ticket sales. How many adults and how many children attended the recital? We have to define our variables and create a system of equations. The question tells us what we're looking for. We want to find out how many adults attended the recital and how many children. So we might let A equal the number of adults, and we can use any variable we want, and maybe C equal number of children. If you want, you can always use X and Y. It doesn't matter. You just have to identify what does each variable represent. So now we need to write our equations. We need to come up with two equations. They will both involve the letters A and C. The first one is easy. There were 220 people there all together. The number of adults plus the number of children must equal 220. There's our first equation. The second equation will deal with the money part of it. Each adult ticket costs $9. There are A adults times $9 per adult. So the total amount of money collected from adult tickets would be 9A. Plus, there are C children, and each children's ticket costs $6. So the total amount of money collected from children's tickets would be 6 times C. And the total amount collected for both is $1,614. There's our second equation. So to solve this system, we're going to use a method of substitution. Remember, you need to choose one of the variables in one of the equations and get it by itself. It is way easier to get either A or C by itself in that first equation. If you wanted to get A by itself in the second equation, it would involve dividing both sides by 9, which would give us a fraction to work with. Don't want to do that. Same thing if you wanted to get C by itself in that second equation. That would involve dividing both sides by 6, which would give us a fraction on the other side. Don't want to do that. So I'm going to get, and it doesn't matter which one you get by itself. Let's just say I'm going to get C by itself in the first equation by subtracting A from both sides. C will be equal to 220 minus A. And we're going to plug that into the second equation. Wherever we see the C, we're going to replace it with 220 minus A. This is why it's called the method of substitution. You're going to substitute for C in the second equation what we found C to equal from the first. And by doing that now, we have an equation that no longer has two variables. It only has one variable, the variable A. We can solve for A. We would first multiply out the brackets. So 9 times 220 is 1,980. Oh, you are, I'm sorry, yeah, thank you. Thank you. That should be 6. So it's 6 times 220. Is 1,320. Minus 6A, because you're going to multiply the 6 in front by the minus A as well, equals 1,614. So 9A minus 6A is 3A, plus 1,320 equals 1,614. We'll subtract the 1,320 from both sides. So 1614 take away 1320. So 3a will equal 294. And then we would divide both sides by 3 to get a by itself. So 294 divided by 3 is 98. That's what a is. That will be the number of adults. Okay, that'll be the number of adults. So to find out what the number of children are, take this equation up top, that C is 220 minus A. We've now found A to be 98, so that will be 122. So this means that there were 98 adults and 122 children. At the recital. And we can check that, verify our solution, going back to the information that we were given. The first thing is that we were told that there were a total of 220 people. That was the first thing we were told. If we take our 98 adults plus 122 children, if we add those together, we get 220. So that one works out. The second thing we were told is that they collected $1,614. So if we take our 98 adults times adults pay $9 a ticket plus our 122 children, and the ticket prices for children are $6 per ticket. If we work this out, 98 times 9 plus 122 times 6, we do get the correct total. So we see that our solution is correct. It satisfies both of those conditions. All right. So example 2, solve using substitution. So remember, you need to look at the two equations and isolate one of the variables in one of the equations. And in this case, that second equation is really easy to work with. We can get a by itself by dividing both sides by 2. So not only do we get a by itself, but in this case, we actually get our answer for a. Because that second equation has only one variable in it, when you get a by itself, we've already got one of our answers. So to find out what b is, we'll have to use the other equation and sub it in. Now, the nice thing about this first equation also is that that first term is 2a. Well, we already know from the second equation that 2a equals 50. So we can just sub that in, or we can let a equal 25, which we found from the first or second equation. 2 times 25 still gives you that 50 there. But if you subtract the 50 from both sides on the right, 80 take away 50 is 30. Then divide both sides by 3, and b will equal 10. There's the equation. And remember, I mentioned this yesterday, that if you want to write it as an ordered pair, you just would put it in alphabetical order. Our two variables are a and b. A obviously is the first letter of the alphabet. B is the second. So if you're going to write it as an ordered pair, do it all alphabetically. All right, looking at example 3, solve using the method of substitution. Again, choose one of the variables, isolate, or one of the equations, isolate one of the variables. I think the easiest way to do this would be to take that first equation and get the letter y by itself by subtracting 0.4x from both sides. So we take that and sub it in for y in the other equation. Instead of 5 times y, it'll be 5 times 6, take away 0.4x. So again, you're substituting what you found y to equal into y in the other equation. So when you multiply out the brackets, negative 5 times 6 is minus 30. And negative 5 times negative 0.4 is positive 2x. 1.2x plus 2x is 3.2x. And as well, we will add the 30 to both sides, which will give us 48 on the right. Final step would be to divide both sides by the 3.2. And our answer is 15. To find y, we'll use the equation that we wrote above, that y is 6 minus 0.4x. We found x to be 15. So 0.4 times 15 is 6. So y will equal 6 minus 6, which is 0. If we write this as an ordered pair, it'll be the point 15 comma 0. And if you're also asked to check your solutions, talked about this yesterday, you need to show the check. Each equation has the equal sign that divides it into two sides, the left and right. When you plug your solution in, you should get the same number on both sides. For the first equation, the left side is 0.4x plus y. This right side is just 6. So the left side must equal 6. When you let x equal 15 and y equals 0. So 0.4 times 15, we actually did that above, actually no we didn't, is 0.4 times 15. We did do it above it, 6. So this is going to be 6 plus 0, which is 6. So it checks for the first equation. Now we need to check for the second equation. 1.2x minus 5y should equal 18. 1.2x, which is 15, minus 5 times 0. So 1.2 times 15 is 18, and 18 minus 0 does equal 18, so it checks. It checks. So again, if you're asked to check, you need to show that. Question B. First equation, it's really easy to get x by itself. You would just subtract the 0.03y from both sides. So x will equal 10 minus 0.03y. And that's what we sub in for x in the other equation. And so by doing that, we now have a new equation that has only one variable in it. That is the variable y, so we can solve for y. First, we'll multiply out the brackets. 10 times 10.4 would be 104, minus 10.4 times 0.03. Is 0.312y, plus 0.75y has to equal 980. If we combine those two y terms, I've already got the 0.312, which is negative. So let's just multiply by -1 right now. That'll make it negative, because you have to add it to 0.75y. It gives us 0.38y. 438, excuse me. And that must equal on the right side. I've got 980. I need to subtract 104 from that. So if it was 980, take away the 100, that's 880. Take away 4 would be 876. So we have to divide 876 by 0.438. Divide, not times. So y will equal 2,000. To find x, we can use this equation that we wrote above. That x equals 10 minus 0.03 times y, which we found to be 2,000. And 0.03 times 2,000 is 60. 10 take away 60 is negative 50. So we're saying that the solution is negative 50, comma, 2,000. And if we're going to check though that answer, we start with the original equations. So x, which is negative 50, plus 0.03 times y, which we found to be 2,000. Has to equal the right side, which is 10. So 0.03 times 2,000 is 60. So it's negative 50 plus 60, which does equal 10. So that one works. We need to check the second equation as well, though. So 10.4 times negative 50 is negative 520, plus 0.75 times 2,000. That'll be 1,500, I think. Yep. And you're going to add negative 520, which gives you 980, same thing as on the right. So we've just shown that our answer is correct. It checks. right? So it checks. So this next one, even though we've got some fractions involved there, it doesn't change the way it's done. You need to get one variable by itself, and it's pretty easy to get y by itself in that first equation. You would move the 8x over by subtracting it and add the 2 to both sides. That gives us positive y by itself. And that's what gets subbed in for y in the other equation. And you can use your calculator to help you do this. If you want to do 1/4 times -8, I mean, that's going to be -2, but you can do it in your calculator. Using brackets, go 1 divided by 4, close the bracket, times -8. That gives you your -2. So this will be minus 2x. And then 1/4 times 2 would be positive 1/2. 3x minus 2x is 1x, and if you move the 1/2 over by subtracting it from both sides, x equals -1/2. So to find y, we'll take that value of x and put it into this equation that we wrote above here that has y by itself. -1/2 times -8 would be positive 4, plus 2 is 6. So again, if we write this in alphabetical order, x comma y, -1/2 comma 6 is our answer. And that's what we need to use for our check. For that first equation, the right side is 0, so the left side must work out to 0 as well. Eight times -1/2 is -4, plus 6 is 2, minus 2 does equal 0. So it works for the first equation. Now we need to check the second equation as well. Again, the right side is 0. X is -1/2. Y is positive 6. 3 times -1/2, you can write 3 as a fraction, 3 over 1, and then it's top times top, bottom times bottom. Same thing with the second part. The 6 is 6 over 1. 1 times 6 on top, over 4 times 1 on the bottom. 6 over 4 reduces to positive 3/2, and -3/2 plus 3/2 does equal 0. So it checks. And you can definitely use your calculator to help you with that check. Now, for question D, there's some extra work that we have to do here because there's fractions in both equations. So what I'm going to do is I'm going to start by multiplying both equations, starting with this top equation. Multiply all the terms by the common denominator, which would be 6. You've got denominators of 6, 2, and actually 1 on the right. The least common denominator is 6. So I'm going to multiply that first equation by 6. So the 6's will cancel for the first term. The second term, 6 divided by 2 is 3. Y equals 2 times 6, which is 12. So there's my first equation with no denominators. The second equation, the common denominator would be 15. So I'll multiply all the terms by 15. That should be minus, not plus. Equals 0, which is also multiplied by 15, but 0 times 15 is still 0. So 15 divided by 5, actually negative 15 divided by 5 is negative 3x. Negative 15 divided by 3 is negative 5y equals, and 0 times 15 is still 0. So there's the second equation without any denominators. So these are now the two equations that I'm going to work with. The first equation, you can get x by itself by subtracting the 3y from both sides. And then we'll take that and sub it into equation 2. X is equal to 12, take away 3y. Once again, we now have an equation that has only one variable. That's the letter y. We can solve for y. Negative 3 times 12 is negative 36. Negative 3 times negative 3y is positive 9y. 9y take away 5y is 4y. And on the right side, when you add 36 to both sides, 0 plus 36 gives you 36. Dividing both sides by 4, our y value is positive 9. And x equals 12, take away 3y. Again, we found y to be positive 9. 3 times 9 is 36. 12 take away 36 is negative 24. So we are saying that our solution is negative 24, comma 9. And that's what we need to use in our checks. Pardon me? Oh, it is 4 times 9 would be 36. So we would have found out if we checked, when we checked it, that we had a wrong answer. But it's nice to find it first. Thank you. So that's 27, and that's negative 19. 15, sorry. Negative 15. So, checking our solutions. X over 6 plus y over 2 should equal positive 2. Our second equation to check is negative x over 5 minus y over 3 should equal 0. So x is negative 15 over 6 plus y, which is 9 over 2. Negative 15 over 6 can be reduced by dividing top and bottom by 3. You'll get negative 5 over 2 plus 9 over 2. Those two have a common denominator, so you can put them together. Negative 5 plus 9 is 4 over 2, which is 2, so it checks. Both sides equal 2 when x is negative 15 and y is 9. Now for the second equation, you already have one negative sign there. X is also negative. So negative negatives become a plus positive. It'll be positive 15 divided by 5, which is positive 3, minus 9 divided by 3 is also positive 3. 3 minus 3 equals 0. Okay, so it checks. It checks. Okay? So we're going to stop there. Your assignment, page 475 to 477, questions 5, 6, and 9 through 14, which you're going to hand in for marks. Monday we'll learn about another way to do this algebraically, another way to solve systems of equations algebraically, known as elimination. So we'll learn about that. We'll spend a couple days on that. And then you're going to have your next unit exam sometime next week. towards the end of the week based on chapters 8 and 9. Yes. Yep.